Hello, my name is Svanrak and this is a guide how to make a DCG hologram. DCG standing for dichromate gelatin hologram. Enjoy! Step 1. Checking the glass. The first step when making a hologram is to check the glass. Glass is made in a factory by pouring molten glass on a bed of molten tin. Glass has a lower density than tin, so it floats on top. That's why it's called float glass. The floating glass forms an almost perfectly flat surface on the molten tin. Molten tin is also colder than molten glass, so the glass cools down when it touches the tin. New glass is constantly poured at the beginning of the production line, so the older glass is getting pushed forward. This pushing motion forms a pattern of parallel lines in the glass. You can make this pattern visible if you shine an expanded laser beam on the glass at a very steep angle and look at the light passing through. Depending on the orientation of the glass, you will see one of two different patterns. You will either see a pattern of parallel lines, or when you turn the glass 90 degrees, you will see a wood grain pattern. To get the optimal hologram, the glass should be oriented so you see the parallel lines pattern. If the correct orientation of the glass is neglected, there will be scatter in the final hologram. With a pen, you can draw an arrow on the glass indicating the direction of the pattern. When you cut the glass a little longer in the vertical size than in the horizontal, you will be able to remember in which direction the lines were running. Step 2. Cutting the glass. I use standard float glass for making holograms. Optical grade glass doesn't yield better results. First, I draw a sketch of how I want to cut the glass. As you can see, there is an arrow on the glass indicating the direction of the parallel lines pattern that I checked for under green laser light. I will cut my plates a little taller than wide. That's how I can remember how the pattern is oriented. In this case, I'm cutting plates sized 21 centimeters by 14 centimeters. The glass thickness is 2 millimeters. I use kerosene and a brush to lubricate the glass at the cut line. I'm using kerosene instead of other oils because it quickly evaporates and leaves little residue. I take a glass cutter and cut the glass in a sweeping motion, applying constant pressure. While cutting, you should hear a clean hissing sound. The cut puts stress on the glass. The kerosene fills the cut and keeps it open. As time passes, the glass heals, so you should break the glass quickly after cutting. Always make the shorter cut first. To get the best cut possible, you always want to cut the glass plate in halves. If your first cut failed because you released pressure halfway through the cut, you can always turn the glass plate around and try again. I place the brush handle under the cut and lightly press down on both sides with my hands. This should yield a clean break of the glass. Once all the plates are cut, I check them for imperfections or big scratches. These are most easily observed by shining through the glass with a red LED light. Don't throw away scratched glass plates. They can still be used as cover plates later on. About 30% of the glass you buy won't be good enough for making holograms. On a side note, you always want to work with the thickest glass still acceptable for your project. Thicker glass is easier to handle and performs better later on in the process. Step 3. Cleaning the glass. The glass should be cleaned very well. If any dirt remains on the glass, you get an uneven coating later in the process. In the first stage of cleaning, I use warm water and some window cleaner to get all the dirt and kerosene off. Next, I place the glass into a tank of hydrochloric acid. The concentration is about 3% acid in water. The glass will stay in this tank for at least 20 minutes, but not longer than 12 hours. If the glass stays in the tank too long, an oxide layer will form on the glass, making it harder for the gelatin to stick to it. After 12 hours, I take the plate out of the acid tank and scrub it with a very soft sponge and dishwashing soap. I scrub it from left to right and in an up and down motion. When scrubbing, you will notice that one side of the glass feels a little rougher than the other side. One side will provide more friction when scrubbing it and also make more of a squeaking sound. This is again due to the manufacturing process of the glass. The rough side is the one that had contact to the molten tin. The gelatin sticks better to the rough side of the glass, so it's the side that should be coated. To remember which one is the rough side, you can store your plates tilted at an angle of 30 degrees, with the rough side always facing down. This also gives you the advantage that in case any dirt or dust settles on the plate, it will go on the top side of the glass, while the good side stays clean. After scrubbing, I rinse the plates with deionized water. This water is free of minerals and will leave no residue when drying. I put the wet plates into a drying cabinet, which is at least 30 degrees warm. There is also a dehumidifier in the cabinet to speed up the drying. The air in the cabinet should be filtered so no dust settles on the plates. Step 4. Preparing the gelatin. This is how I mix the gelatin that I will use to coat the glass. My formula today is 367 grams of water, 68 grams of gelatin, and 8 grams of ammonium dichromate. This is a lot of dichromate in gelatin and will yield a rather thick emulsion. This recipe is optimized for using a low-power green laser. If you do have access to a blue laser, you would want to make a rather thin emulsion, because then more light can penetrate the emulsion, giving you a brighter hologram. Then your emulsion should be 500 grams of water, 21 grams of gelatin, and 2 grams of ammonium dichromate. Also, if you add 9 drops of Kodak photo flow to that recipe, you will get a cleaner, more even coating. The dichromate will be added in a later step, so for now it's just gelatin and water. The gelatin is very important for the final outcome of the hologram. I've tried many brands, but in Germany the best gelatin you can get is Gelita Non Plus Ultra 220 bloom. The bloom number refers to the hardness of the gelatin. 220 bloom is a rather hard gelatin for making holograms. The perfect working environment for making DCG holograms is 24 degrees Celsius, room temperature, and about 60% humidity. Warmer temperatures will make your holograms redder. Colder temperatures will make your holograms greener. In the summertime, when you coat very large plates, you should increase the percentage of the gelatin in the water. This will make your coatings thicker. Nevertheless, I use my gelatin formula all year round. So I put 367 grams of cold water into a beaker. While stirring with a whisk, I slowly pour 68 grams of gelatin powder into the solution. After a few minutes, the gelatin will get very thick. Now I place the beaker into a water bath. I use an electric canner for that, because it can be set precisely to a certain temperature. The temperature of the water bath will slowly rise to exactly 40 degrees. If you accidentally heat the gelatin above 50 degrees Celsius, throw it away. High temperatures damage the structure of the gelatin and result in a bad coating. Keep the temperature at 40 degrees and stir the gelatin every 5 minutes for a total time of 1 hour. After 1 hour, the gelatin will have dissolved completely and will have turned into a honey-like solution. Take the beaker out of the water bath and let the gelatin rest for 12 hours. Step 5. Sensitizing the gelatin. After the gelatin has cooled overnight for 12 hours, I put it back in the water bath and heat it up to 40 degrees. Next, I set up my small glove box that I built for measuring the ammonium dichromate. Ammonium dichromate is a very toxic chemical and shouldn't be inhaled. It's most dangerous when it's in powder form, because then the particles can get airborne. I've built an airlock into the box to safely transfer the beaker with the gelatin in and out. I put my hands into the gloves and open the storage container for the chemical. With a spoon and a little electronic scale, I measure 8 grams of ammonium dichromate and fill it into a little glass bottle. As you can see, the space in the glove box is very cramped. So I first measure the powder, and then in a second step, I put the powder into a beaker. For that, I reopen the airlock and bring in the beaker with the warm liquid gelatin. I remove the tinfoil dust cover and pour in the 8 grams of ammonium dichromate. I remove the beaker from the glove box and put it onto a magnetic stirrer on low setting and low heating for about 10 minutes. Because the ammonium dichromate is now mixed with the gelatin, it is much more safer to handle, because the particles are less likely to get into the air. The next step is to filter the gelatin. For that I use the cheapest Aldi coffee filters. I've tried the more expensive filters as well, but they tend to rip and don't yield better results. It takes about 15 minutes for the gelatin to pass through the filter and flow into the transparent cup at the bottom. While the gelatin is inside the filter holder, it tends to cool down very quickly, making it harder to penetrate the filter. So for thermal insulation, I put a tinfoil cover on top of the holder. From the transparent cup, the filtered gelatin is poured into a special coating bottle. It's a squeeze bottle that can hold about 400 milliliters of gelatin. It has a spout at the top, which is connected by a tube to the bottom of the bottle. When you squeeze it, the bubble-free gelatin from the bottom of the bottle gets forced out first. At the bottleneck, I have drilled a small hole. By placing my finger on the hole while squeezing the bottle, I can control the flow of the gelatin. When I'm finished coating, I make sure to first remove my finger from the hole and then unsqueeze the bottle. Otherwise, the air would re-enter the bottle through the spout, creating even more bubbles. In a final step, the filled coating bottle is placed into an ultrasonic bath for about 1 minute to get rid of the even tiniest bubbles, which make for a bad coating. When switching on the device, all the bubbles rise to the top. Now the gelatin is ready for coating. Step 6. Coating the glass. For the purpose of coating the glass plates, I've built a second glove box. It's actually a dumpster turned upside down with an acrylic glass front and an airlock attached to the side. I take a warm, clean glass plate out of the drying cabinet and place it together with the coating bottle inside the airlock. The glove box guarantees a controlled coating environment that is dust-free. The temperature inside the box should be at 24 degrees and 60% humidity. The higher the humidity and the air temperature, the faster everything reacts, and everything gets harder to control. I put on the gloves from the glove box and pull the plate inside. The clean glass plate is placed into the little tray to catch any excess gelatin dripping down during the coating. My plates will be veil coated, followed by a 5-minute spin on a turntable. With my left hand, I hold the plate on the upper left-hand corner while having the coating bottle in my right hand. I squeeze the bottle while closing the small venting hole at the top with my right index finger. Once the gelatin starts pouring out, I begin coating in the bottom left corner of the plate, move up the left side, then along the top, and then back down again on the right side. All this is done in one continuous motion. The flow of the gelatin should look like a veil coming down. Once the plate is completely covered, I place it on the spin coater. It's an old record player, spinning at 80 rounds per minute. While spinning, the plate, it rests on 3 spacers made from a cut garden hose. The centrifugal forces will even out the gelatin. After 1 minute, I will turn on a 150-watt infrared light that hangs above the turntable and leave the plate spinning for another 5 minutes. The heat from the red light is drying the gelatin. The bulb is hanging 13 centimeters above the plate and 15 centimeters off the center axis. Otherwise, all the light would be too concentrated in the middle of the plate. Once the plate is coated, I'll take it out of the glove box and put it in another drying cabinet. It should stay in there for at least 12 hours before being exposed. The temperature inside the drying cabinet should also be at 24 degrees and 60% humidity. The slower the plates are drying, the better. The door of the cabinet is left open to ensure good air circulation and to not trap any moisture, which would result in a milky-looking hologram. Step 7. Building the exposure setup. I start by sharpening and flattening the nails on a grinder. Most nails that come out of the factory are wonky. The nail tip should be very pointy and the nail head has to be as flat as possible. These nails will be the feet of the exposure setup. It all relies on the 3-point contact principle. With 3 points of contact, there is no room for wiggling and you get the most stable setup. My model is a 3D silver print of a woman. The model is glued to a small brick. The brick is spray painted glossy white for better reflection and has already 3 spacers glued to the top side. The gluing of the feet is done with epoxy resin to ensure a very stable bond. I mix part A and B on a piece of glass so there is no dirt getting in. Then I thoroughly mix it and quickly glue the nails to the underside of the brick. The exposure setup is very simple. The laser passes through a rotatable polarization filter, gets redirected by a mirror, and then expanded by a concave mirror. The model is placed on a solid concrete table resting on inner tubes. There is no need for a super expensive optics table with Newport legs. Inner tubes do a superior job. By holding a little nail into the expanded laser, you can determine at what angle the light is hitting the model. Like with a sundial, you can adjust it so the light is coming in correctly. The plate will be exposed Denizuk style with a reference beam coming in between 45 and 56 degrees. You can use a protractor to check for the correct angle. Step 8. Exposure. To maximize efficiency, I coated the plates in the biggest size possible. Now I have to cut them up. First, I recheck the coating job and the glass quality. Sometimes it's necessary to clean the uncoated side with window cleaner. For this hologram, I've coated very thin glass. It's only 2 millimeters thick. I've prepared a little board to assist me in cutting the plate into 4 separate pieces. On the board, I've glued strips of duct tape that act as spacers for the cutting job. Without the duct tape, the glass would break in undesired areas during cutting. The emulsion side touches the duct tape and gets damaged by it. But as long as this is happening only on the outer perimeter, that's okay. I place the brush handle under the glass, apply pressure on both sides, and thus facilitate the break of the glass. In a light, tight box, I transport the plates to the exposure room. In the exposure room, the humidity should be at 60% and the temperature at 24 degrees. I put the plate emulsion side down on the exposure setup. Next, I put masking tape around it on the upper side of the plate. This is done to avoid internal reflections. The emulsion won't be exposed where the tape is covering it. After the exposure, the tape is removed and one can see the difference between the taped off unexposed areas and the exposed film. The exposed gelatin will be slightly tanned. Depending on the length of the exposure, this tanning will be stronger or lighter. With a brush, I paint the spacers black so they won't create unwanted reflections in the hologram. I use acrylic paint for that. You could also use oil paint, which won't be dry by the time of the exposure, creating movement and thus making the nails invisible in the final hologram. I use strong neodymium magnets to fixate the plate to the metal spacers below. The shiny magnets are covered with masking tape, so they don't scratch the glass. The trick will create a very stable recording setup. DCG is very forgiving to overexposure. One can expose 10 times longer than actually necessary and still get a good hologram. Perfect conditions for making DCG holograms is warm and dry. You want the humidity to be around 60% and the temperature at around 24 degrees. The room temperature is the key factor. The colder it gets, the harder the gelatin becomes and the more light power you need to make the hologram. Below 10 degrees, it becomes very difficult to shoot DCG holograms at all. By the way, in the first minute of the exposure, you can move the beam without a problem. As long as you don't move the table, it's all good and you can get away with a lot. In this setup, the exposure is done with a 100 milliwatt green diode laser at a wavelength of 533 nanometers. But I would much rather use a blue laser because DCG is 10 times more sensitive to blue light. The laser passes through a shutter and then through a rotatable polarization filter. This filter can be turned until the light is perfectly polarized. You want to turn it until you see the least reflection bouncing off your glass plate and the most light passing through. The plate is exposed for 4 minutes and then left in the dark for 5 minutes. This is called the dark reaction and can be extended up to 3 hours, which can increase the brightness by about 10%. If you want to make a master of a not so stable object, you can underexpose the plate by 30% to 40% and then let the plate rest afterwards in the dark. Come back after a week and develop the plate. It will turn out just as bright as a sufficiently exposed hologram. Step 9. Developing. 5 minutes after the exposure, I come back into the room. I remove the magnets and take the plate off the setup. And then I carefully remove the masking tape. I walk to the developing area and place the plate into the fixer bath. All the baths have a temperature of 24 degrees. I would highly recommend to wear a respirator with active charcoal filters when working in the developing room. Also, very good ventilation with a fan is very important. For fixing, I use Tetinal Superfix. The dilution ratio is 1 part fixer and 3 parts of water for a total of 4 parts. One could also use Kodak Professional Fixer, but I don't have any experience with that product. I tilt the tray until all the liquid accumulates in one side of the tray. I then put the plate inside and level the tray again. A continuous wave of fixer will flow over the plate. You have to rock the tray constantly for the chemicals to get everywhere. I watch the plate and observe the slow disappearing of the dichromate yellow starting from the center of the plate outwards. The total time the plate should remain in the fixer is highly dependent on the age of the film and how fresh the fixing solution is. The emulsion on this particular plate is very young, so I keep it in the fixing bath just until all the yellow is gone. If the emulsion would be older, I would take it out when it's still slightly yellow. In this case, the fixer is super fresh, so I fix the plate for under 30 seconds. Holding the plate on the sides, I proceed to the washing bath. The plate is supposed to be dropped in the bucket. It contains just water and is intended to remove all the residue fixture from the plate. Depending on the plate size, I keep it inside the bucket for at least 1 minute and up to 20 minutes. I slowly pull the plate out of the water in one continuous motion. In the next step, the plate will go through a series of 4 isopropyl alcohol baths of increasing concentrations. It's 54%, 59%, 84%, and 100%. This process will gradually replace all the water in the emulsion with alcohol, which will then evaporate after the final bath. I immerse the plate quickly into the 54% alcohol bath. Bigger plates are just dropped into the tank, and depending on the size, left in each bath for at least 45 seconds and up to 4 minutes. Today, the plate is very small. Such a tiny plate is good after 25 seconds in each bath. When I pull the plate out of the 54% alcohol, the gelatin will be very soft and gooey. I hold it upright in front of me for about 25 seconds and watch how the gelatin reacts to the air. The alcohol will evaporate slowly from the edges towards the center. I don't want the alcohol to dry off completely. If I let that happen, the gelatin structure will collapse. The alcohol should evaporate to the point where the emulsion is barely wet and almost starting to dry. You know this point has been reached because at the top of the plate, the gelatin will look a lot like snake skin. Once I see that snake skin, I lower the plate slowly into the next bath. Going from 54% alcohol to 59% is a critical step. The plate will remain another 25 seconds in the 59% alcohol bath. Inside the tank, the emulsion will turn from gooey to solid. Coming out of the 59%, the gelatin will have become rigid. It's now closer to being a solid than a liquid. When I take the plate out, it will watch for the snake skin. Once I see it, I slowly immerse the plate into the 84% bath, where it will remain another 25 seconds. After I've taken the plate out of the 84% bath and wait a while, I will start to see a hologram reflection at the top of the plate. Once I see that slight reflection, the plate is ready for the final bath. The 100% alcohol bath can be heated up to 40 degrees, but today it's unheated and at room temperature. I put the plate smoothly into the 100% and it will stay in there for 3 minutes. I take the plate out of the last bath and quickly move to the drying area. The room temperature in the drying room should be above 30 degrees and the humidity below 20% or lower if possible. The plate is dried with a paint stripping gun set to the lowest row setting but on maximum heat. With this tiny plate, the drying motion is not relevant. But if the plates get larger, you would want to concentrate the heat on the lower part of the plate first. Then going from left to right and up, mimicking an L motion. Because gravity assists in the drying, the most part of the alcohol will concentrate in the lower part of the plate. After a while, I will turn the plate 90 degrees counterclockwise and continue the drying. Someone once told me that you cannot over-dry, but you can under-dry a hologram. This is true when using a hairdryer. But if you're using a paint stripping gun, you can over-dry and even burn the gelatin if you leave the gun too long in one spot, or move it too close to the emulsion. After some time performing the L motion, you can concentrate the heat on the middle of the plate, blowing in circles. The plate will become milky at first before turning transparent again. The hologram should appear after 2 minutes of drying. Once I see it, I continue to dry for about another 3 minutes. When the hologram is finished, I put it in a plastic, airtight storage container. Inside this container, I have also placed a little cup filled with silica gel. This gel is a drying agent that will bind any remaining humidity. I can store the holograms in the container indefinitely, but I highly recommend to seal them quickly. Step 10. Scraping. For this demonstration, I will use a different hologram than the one I just developed, but the process is identical. I highly recommend to wear a respirator while scraping. You want to protect yourself against the alcohol fumes as well as particles of dichromate gelatin that you scraped off and that are now floating in the air. Be careful that no condensation water from the outlet of your respirator drops on the hologram, which would ruin it. I turn the holographic plate so I can write on the uncoated side. At the top of the plate, I put a piece of garden hose that acts as a spacer, because I don't want the emulsion side to touch the table. Normally, I also put a towel on the working area so the hologram doesn't get scratched, but I forgot it this time. With a pen, I frame the hologram. Everything outside of this frame will be scraped away. It helps to define the vertical and horizontal center lines first and then draw a frame around them accordingly. When I'm finished, I turn the plate again so the coated side is facing me. Now I will begin with the rough removal of the gelatin. I take a damp sponge and move it over the edges of the plate. The sponge will vet the hard gelatin and make it more easily removable. I'll leave a 5mm safety gap between the marked outlines and the sponge damped area. With a razor blade, I remove the excess gelatin. This process is repeated 4 times for every side of the hologram. Now for the precision work. I have attached 2 clamps to my steel ruler, so it's angled at 45 degrees. This way the ruler can't damage the emulsion by touching it. I take a cotton swab and spray it with 100% isopropyl alcohol and move it over the marked line. I place a ruler 0.5 millimeter next to this line and cut the emulsion with the pointy edge of a new razor blade. With the flat side of the same blade, I take off the emulsion. I repeat this process 4 times for every side. Now I prepare for the final cut. Once again, I swipe the emulsion with a cotton swab dipped in alcohol. I use a new razor blade and cut the emulsion on the marked line. With the flat part of the razor blade, I take off the final strip. By leveling the razor blade flat and hitting the cut in a knocking motion, I can remove even the smallest residue of gelatin from the plate. I repeat the cut 4 times using a new razor blade every time. The result should be a perfectly smooth edge. The hologram is now ready for sealing. Step 11. Sealing. The hologram has to be sealed, so the emulsion is protected from outside moisture. DCG is very hygroscopic and sucks the humidity right out of the air. This causes the emulsion to swell, which collapses the fringe structure and makes the hologram invisible. It can be made visible again by redeveloping the plate, but by properly sealing it in the first place, this is not necessary. First, I prepare the tools that I will need for sealing. I heat the rim of a small plastic cup, and with a nail, I form a little spout at the top. This will make the pouring of the glue much easier. The hologram should be sealed in a dust-free environment. Otherwise, there will be specks of dust glued onto the emulsion. To avoid this, I'm working inside a laminar flow bench that I've built myself. You can see a wall of straws blowing air towards me. This guarantees that no dust can enter the work area. I wear a respirator and gloves and even take a shower before sealing, so no dandruffs can get on the hologram. First, I mix the two-part epoxy glue, which I will use for the sealing. UV glue can be used as well, but it has a tendency to yellow over time and generally makes for not as strong of a bond as epoxy glue does. The epoxy glue consists of part A and B. The instructions for my brand of glue are 12 grams of resin and 6.6 grams of hardener. Today I'm using a budget glue, but if you have a hologram that you want to seal forever, I recommend the product HXTAL-NYL-1. This is a special epoxy glue which is mainly used in museums for archival purposes. I stir the glue for some time above the heat gun set to the lowest setting. Warm glue makes this much better than cold glue. If you want to get really fancy, you could also place the cup in a vacuum degassing chamber. That will get rid of all the bubbles getting created during mixing. Sadly, these are expensive, so I don't have one. With the photographer's lensed dust blower, I blow any possible dust off the hologram. With the heat gun set to the low setting, I blow over the plate and warm it up. Warm glass bonds much better with the epoxy glue. Next, I have to choose a piece of glass that will cover the plate. This cover plate should be 3 centimeters bigger on all sides than the hologram you want to seal. There should be some overlap as a safety margin when gluing 2 pieces of glass together. The cover glass will be cleaned and dried in the same way I demonstrated before in my cleaning glass segment. I don't recommend to glue glasses of different thicknesses together, as this will decrease the longevity of the hologram. Glass of varying thicknesses will expand and contract in different ways and thus work against each other, weakening the epoxy bond over time. I pour the glue on the hologram. The shape of the poured glue should look like a T with 2 legs. I try to avoid making any bubbles. Once the glue has been poured on the glass, I blow with the heat gun over the hologram. This will heat up the glue, which will make it more fluid and at the same time pop most of the bubbles in it. From the drying cabinet, I fetch the cover plate. I lower the plate very slowly and then rock the glass around a little so the glue disperses all over. Very slowly, I tilt the top cover plate and lower it towards the bottom hologram plate. You really want to do this in the slowest way possible, because if you do it too fast, there is a high chance of creating new bubbles. If everything works perfectly, the glue should move from inside out, covering the entire plate. Next, I bring the glass sandwich to a different area where I let it cure. I put 4 cinder blocks wrapped in saran wrap around the sealed hologram. I want the least surface area from the blocks to touch the soft glue, so I only make them touch with the corners. The cinder blocks will prevent the cover plate from sliding off, and because they touch the plate only with the corners, I will be able to remove them easily once the glue has hardened. It normally takes at least 24 hours for the epoxy glue to cure. For a tighter bond, the curing should be done in a warm place. In a final step, I put a weight on top of the hologram. The weight is removed after 1 hour. It's just there to apply some initial pressure on the glued glass plates. If the weight is left on there for too long, there will be visible force lines in the final hologram. After about 12 hours, the glue is sufficiently cured to bond both glass plates together, but still soft enough to be peeled off. Big droplets of glue that have formed on the underside of the hologram should be removed now. With the help of a little isopropyl alcohol and a razor blade, this works quite well. Step 12. Grinding. The hologram is finished and sealed at this point. Now it's all about grinding off the sharp edges from the glass, making the hologram more safe and presentable. There are machines that grind perfect edges on glass plates. If you don't want to do this yourself, you can give the hologram to a workshop and they will do an amazing job. Nevertheless, I will demonstrate a very low-budget approach to grinding glass that can yield some very nice results. The machine I'm using is a Kristall 1 glass grinder with interchangeable grinding bits. I highly recommend wearing safety goggles for this work, as tiny shards of glass are constantly flying in your face while grinding the edges. A respirator is also advisable, so no glass dust can get into your lungs. I forgot to do it this time, but normally I cover the entire front and back side of the hologram with tape, leaving only the edges exposed. This will prevent the surfaces from getting scratched. Prior to grinding, and only if deemed necessary, you could cut the sides of the hologram with a rotating tile saw. This only makes sense if you need to take off huge chunks of glass that would take forever to grind off. When using a tile saw, it's a good idea to leave a 5mm safety margin between your cut and where you want your final edge to be. Always keep in mind that the wider the rim between the emulsion and the actual edge of the glass, the longer your hologram will last. The humidity in the air will eventually destroy every DCG hologram, but the wider the rim, the more distance the moisture has to penetrate before it can reach the emulsion. When grinding the glass, you always want to grind the top and bottom edges first, while holding the glass plate at a 45-degree angle towards the grinding bit. This is called chamfering and will create a triangular shape. Only in the final pass will you level the plate by pressing it flat against the grinding bit, taking off the tip of the triangle. This will prevent the glass from chipping. The grinding bits on this machine can be changed. First, I start with a very rough bit and then work my way down to the finer bits. In total, I have 3 bits. They are all color-coded. The roughest is easily recognizable. The middle one is orange, while the finest bit is blue. With each bit, I grind every edge multiple times until it looks nice and is smooth to the touch. For a plate this small, the grinding takes about 90 minutes. After the grinding is complete, the hologram is finished, and the final step is to remove all the protective tape from the top and bottom side. Any residue from the tape can be easily removed with isopropyl alcohol. Holography is my life's passion, and I've dedicated an enormous amount of my time to it. I spent 8 years working with DCG, and it was really difficult to get all the information that I put together in this video. I wish someone would have given me this information when I started out. That's the reason why I made this guide. Finally, I want to show you a video of the best hologram I ever made. The object is a 3D model of a stairwell I designed in 3D software and 3D printed in silver. I'm sitting on a dike in my hometown in Hamburg, Germany, flipping it through my fingers. This hologram combines everything I love about holography: the colors and the depth, a crystal clear glass plate with a 3D image that seems impossible but looks so very real. My dream is to one day make a hologram just like that, but 2 meters high and 1 meter wide, and then put it somewhere in the desert. Zum Schluss möchte ich mich noch ganz herzlich bei meinem Bruder Miro und meinem Kumpel Stefan bedanken, die mir geholfen haben, dieses Video zu machen. Vielen Dank, Jungs.
Nice. Schon down again, huh? Represent.